Alright students, so you just watched a video on adding fractions according to the Common Core. And it's a good video, but I wanted to just go through a couple more problems with you, make sure that you've got this from a Common Core perspective rather than that perspective you probably got in elementary school where you were just memorizing what you were doing. So we're going to start with an example where we have like denominator. Remember, if we have the like denominators, it means that we have the same size of pieces. So if I have 3/5 and 4/5, the pieces are the exact same size. So what I want to know is, what is the total number of pieces that I have? So if I kind of think of this using the combining approach, remember combining approach for addition, we start with each addend in a separate set. So this addend has 3, and rather than try to draw what a fifth looks like, I'm using x's. Each x for me equals a fifth. Right? And over here, I've got 4 of them. And so then when I dump them together, I count them up. I say, all right, how many total pieces do I have? And I have 7. And then I have to say, hey, I'm not counting whole objects here. Each of my objects is a fifth. So what I have is 7/5. Now the reason I did these x's is because I kind of just wanted to prove a point here. Let's say these were 8s. My way of doing the problem would exactly be the same. I would say I've got 3 pieces, I've got 4 pieces, I count them up all together, I've got 7 of them. The only difference is my pieces have a different name. So my final answer would be 7/8 rather than 7/5. So the size of the pieces changed, but how many pieces I had remained the same. So now let's do an example where I do not have common denominators. So let's say I've got, we'll go with 3/5 again. And let's add that to 3/4. So if I try to do this the same way, 3/5, well fine, I could do that. I could come over here and say, all right, my x's are fifths, right? I better not use x's again because that would be pretty confusing. So I guess I'll use asterisks, right? So those are fourths. And when I dump everything together, I end up with 3 x's, and I end up with 3 asterisks. And sure, I can count them up and say that I have 6 pieces, right? But I don't have a name to give to these pieces because they're different sizes. So I can't add fractions together that look like this. So instead what we have to do is get that common denominator. So what I want you to tell me when I'm asking you, especially in an essay format, is what I want you to tell me is I need the same size pieces. So when you're adding fractions, you need to get the same size pieces. You don't have to draw me pictures, but you do need to explain that. You need to get the same size pieces. So we'll take 3/5 and we'll take 3/4 and we'll change those into equivalent fractions where the pieces are the same size. And my fastest way to do that is to multiply the top fraction by 4/4 and the bottom fraction by 5/5. So now I have 12 pieces that are 20ths in this first fraction. And I have 15 pieces that are 20ths in the second fraction. Right? So I got the same size pieces. So that was my step 1. My step 2 is count the pieces. I count the total pieces. All right, so my total pieces is 12 here, 15 here. So that's 27 total pieces. And then I've got to put my fraction bar in so that I can name my pieces. I have 27 pieces, and my pieces are 20ths. All right, so now I am going to do a subtraction problem. Same type of idea here. Let's start with, I'll throw a mixed number in here for the heck of it. Let's do 2 5/8. And let's subtract from that 1 3/8. And we could do this in a number of different ways, but I think what I want to look at doing is saying, how many total 8s do we have? To start with, how many are we removing? So here, I've got 2 wholes, and I'm talking 8s here. So each whole is made up of 8 8s. So in my 2 wholes, I have 16 8s, right? Plus these 5 here that I've got. So this is really 21 8s, right? And over here, I have 1 whole, so that's 8. Plus 3 more is 11 8s. So I'm going to do the takeaway approach. Okay, so I'm going to have 21 8s. I think I got it. All right, so I've got 21 8s. And I remember my x's is because I'm lazy and trying to prove a point. Right? Each one of my x's stands for an 8th. So now I am going to remove 11 of those. All right, so there's 7 gone. 11. All right, and then I count to see how many I have left. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 pieces left. So there's my 10. And then the bottom of my fraction names my pieces, and my pieces are 8s. So I have 10 8s. Okay? So if you were explaining this to me, you would need to use terminology to say, hey, I started with 21 8s. I removed 11 of the 8s. And so I was left with 10 8s. Or you'd say I had 21 pieces. I removed 11 of the pieces. All the pieces were 8s. Something like that. All right. Again, just to kind of prove the point, I could come back here and change that to 9ths. And everything pretty much stays the same. These x's are still the same because they each just represent how many pieces. Okay? So I've got 9ths, and when I go to give my final answer, they're 9ths. So the point I'm trying to make here is when you're doing addition and subtraction, it's about the quantity of pieces, just like it is with whole numbers. It is the exact same thing, just with the fractions, I've got to name the size of my pieces. When students were learning whole numbers, the pieces were always wholes, so they never had to worry about naming them. Now we have to name them. So let's do one more example. Let's put some non-like denominator. So how about 23 20ths, and let's subtract 3/10. All right, so my issue with this one is I could go ahead and draw my circle, right? And I could write 23 x's in there to stand for 20ths. But then when I go to do the takeaway part, I have a problem, right? Because this says to remove 3 pieces that are tenths. I don't have any tenths to remove. So I've got to get a common denominator here. So I can do that by taking 3/10, right? And if I multiply by 2/2, I end up with 6/20. All right. So if I have 23/20, and I'm going to subtract 6/20, I've got the same size pieces now. And I start with 23 pieces. And I remove. I'm writing it rather than showing the picture. 6 of them. And I'm left with see, that would be 17 pieces, right? And my pieces are called 20ths. So that would be my answer.